Let's continue our study on significant figures. There are different rules for adding and subtracting versus multiplying and dividing. For adding and subtracting, you have to round your answer to the least number of decimal places, which really is the least precise number. We'll talk about what that means in just a second. Okay, so let's go through and talk through the process of how to solve this problem. What I like to do is I like to label my numbers first because I'm visual. You do not have to always do this unless it helps you. This number here has one decimal place, or one number after the decimal. This one has 2, and this one has 3. So for our answer, we want it to be to the least amount, which is of course 1. So I solve my problem just like normal with the calculator. And again, being a visual person, I have to do some rounding. So I count over one decimal place. I'm going to put a little marker. I'm going to look at my 7 to figure out what to do with my 0. Of course, 7 rounds the number in front of it up. So I get 16.1. Let's do a second example here. Let's say that you were asked to add together the numbers 350 plus 8. We know that this is 358. It's a pretty simple math calculation. Let's look at our decimal places, or our least precise number. So when I look at my 350, I know that 0 doesn't count as a sig fig based on the previous slide. So the 5 is in the tens place, and it's my least precise number. And then the 8 is in the ones. When I round, I have to round to the tens. So I come over here to my 5, I put a marker, and then this 8 is going to round my 5 up, so I get 360. Okay, let's move on to multiplying and dividing. Multiplying and dividing use the same exact rules that you used previously on the last slide. We're going to round our answers to the least number of sig figs. So again, visual person, I'm going to label these. 2 sig figs for that one, 4 for this one. So my answer wants 2. When I solve this problem, I get this. 356.86 ... I want 2 significant figures in my answer. So I'm going to count over 2. I'm going to focus on the 6. That 6 causes the 5 to go up, and I get 36. Well, that's ridiculous. I can't round 356 down to 36. So because I had to get rid of the 6 there, I replace it with a 0. So the correct answer to this one is also 360. Let's move on and try a few on our own. What I would like you to do is pause the video and try the following practice problems. Please check your answers. I've circled a few that I'd like to discuss. So for the first one there, the correct answer is 400. This one right here, the first one I have circled. When you solve that problem, your calculator is going to provide you what I have in blue, 374. I have to focus on the least precise number in my calculation. So 500 here is the hundredths place. And then the 126 would be the ones. Well, the hundredths place is less precise than the ones, so I have to round all the way up to 400. For the one below it, I have 2 decimal places in the first number. I have 4 in the second. When I go through, I need 2 in my answer. So with the number the calculator provided here, I would count over 1, 2. That 6 would cause this 5 to round up. And so yes, I end up getting the exact same answer I started with. And that's okay. That's going to happen sometimes. For the multiplying and dividing, the first one there, you need 4 sig figs, so that wasn't that hard to figure out. But the biggest mistake I see with a problem like this is my students sometimes will count the zeros in front when they start counting for sig figs. Please remember, when there is a decimal, zeros at the end would count, but zeros in the beginning don't. So you start counting at the 1, and you would count over 1, 2, 3, 4. This 6 causes this 4 to round up to a 5. The last one there wasn't very fair because we haven't yet talked about scientific notation. This one has 4 sig figs. This one has 2. The calculator provides you the answer 301.92. So you're like, okay, I know I have to round. Well, you count over 2. This 1 does not change the 0. So you're like, okay, I'm going to get 300. The problem with that is, of course, that that's only one significant figure. We saw a few slides ago that it's okay to put a decimal at the end of a number. So maybe I could try that. 300 point. Well, the problem with this is now I have 3 significant figures. Okay, I need 2. So when that happens, when you can't just round either of the 2 ways that I've shown here, you have to use scientific notation. And we'll review that on the next slide. Scientific notation is a given value expressed as a number written using exponents and powers of 10. The decimal always goes after the first real number. So the first number that is not a 0. And as we saw in the previous slides, sometimes we need this to get the correct number of significant figures. To convert in and out of scientific notation, if the decimal has to move to the right, it's a negative exponent. If the decimal has to move to the left, it's positive. I always remember it this way. If I have a small number like this, it's negative. And if I have a larger number like this, the exponent is positive. Okay, let's do a couple and then I'll have you guys try a few. So in our first number here, we know that the decimal technically is at the end of the number to start, and it has to be moved to after the first real number. So I'm going to be moving it right there after the 3. So I count 1, 2, 3, 4. I move my decimal 4 spaces to the left. So my answer will be 3.1 times 10 to the 4th. For the next one, I have a decimal. It's provided. I'm going to move it here. 1, 2, 3, 4. This time I went 4 spaces to the right. So my answer will be 4.56 times 10 to the negative 4th. Please pause the video and try the remaining practice problems. Please check your answers. You needed a positive exponent for one and a negative for the other. For these here, you were moving the decimal. You were already provided the scientific notation. So when it's a positive exponent, the number gets bigger, and when it's negative, it gets smaller. A little trick that I like to tell my students with the negative exponents, always. Notice how this is 10 to the negative 3, and there are 2 zeros in front of the 6, 2. Notice how this is 10 to the negative 6, and there are 5 zeros in front of my number. No matter what with the negative exponent, it's always 1 less 0 than what the exponent is for those. Only the negatives. The positives don't work like that always. But with negatives, 1 less 0 than what the number provided is. Let's move on. We're going to discuss the metric system, hopefully something you've seen before. It's the universal language of scientists. We have a variety of things called base units, which basically just mean that they don't have a prefix in front of them. For mass, that unit is grams. For volume, it's liters. For length, it's meters. Time, it's seconds. For temperature, it's something called Kelvin, which we'll discuss in more detail later. We're going to solve these using this little chart that I have here. Okay. Let's go through. So let's label some things. The B stands for base. Your base is always a single letter. The capital M is mega. The K is kilo. H is hecto. The capital D is deca. Lowercase d is deci. C is centi. M is milli. This funny looking U is called micro. And N is nano. Okay. The other spaces that have no names are placeholders as well that need to be included when we solve these. Let's do one together. So we're going to do this first one. Anytime you see a single letter, it's the base. So what we're going to do for this one is, since it's just an M, we start at the base. So we're going to start here. And then when we have two letters, we focus only on the first one. So we're going to go to the M, lowercase m. So I'm going from B to M. I'm going to count 1, 2, 3 spaces, and I move to the right. So I'm going to move my decimal 3 places to the right. 1, 2, 3, and I fill in with zeros. Okay. Please pause the video and try the remaining practice problems. Please check your answers. Biggest mistake I see with this is when you see an M by itself, you want to use the M in the chart. No. When it is a single M, it stays that way, and it's the base. Okay. All right, let's move on. We're going to start talking about a process called dimensional analysis. Dimensional analysis is a technique or process used to convert from one unit to another using something known as a conversion factor. Conversion factors are special ones. They're really just equalities that we make fractions depending upon what the problem is asking. For example, this equality, 1 foot equals 12 inches, can be written as 1 foot over 12 inches, or 12 inches over 1 foot. Most of these will be things that are provided to you, so you don't have to memorize them. Okay, if you'd like to try the other one, you can as well. We will continue our study of dimensional analysis in our next video.